So we have been discussing about garbage collection and how it works in JavaScript, and like we discussed in the last video, like how everything comes together to sort of manage the memory for the whole language, right? But one thing that sort of we do is we don't consider like it's there, and we sort of take the whole thing for granted, and we unintentionally end up making it hard for the garbage collection to do the memory management efficiently, right? So we should sort of do one or two things here and there to sort of make it easier for it as well, just so that we know that it's there. Since it's clearing things for up, we should mention that these things can be cleared explicitly if possible in places where we can, right? So let's say there is some very huge object or there's some very huge array. So after you're done with it, you can manually set to null. Like that's something that you can do, so that you are sort of notifying the garbage collector, okay, this has no reference, you can clear it now. Something similar can be on the lines of, let's say when you're writing a front-end application, you have event listeners, you have click listeners, and so on. So those you can sort of clear on your own, or you can remove on your own once you're done, so that you can prevent memory leaks and all, right? So those things you can do. And then another thing is global variables. Like try to use less global variables, since global variables sort of forms the root of like the root of a tree, since it's accessible from globally from anywhere in the application. Even if you access it and forget about it, like it won't be garbage collected, right? So one sort of non-intuitive thing I wanted to discuss in this video was you have probably used map in JavaScript. I wanted to discuss something called weak map from a perspective of memory management, like how it serves and what it does, right? Let's say weak map versus map. So let's say we have this key, right? So we have let name equals to maybe let's call it person for map equals to, let's say, name, and the name is Sam or something, right? Then what we do is we define a new map, we do new map, and then we do new map dot set. We get the person for map, and then we set it to maybe, let's say we need the age of that person and 69. So that's done. Now we set the initial reference to null, person for map to null, and then we try to access it again. So we can sort of, let's say we do this, we do console.log new map, and then what we do is we log it again, right? So we can sort of let's log it this entries or something, and then here we log entries, and we do the same thing, but let's say let person for w map weak map equals to name, maybe let's say Jane or something, and then we have cons new weak map equals to new weak map, and then we do this, right? And let's say what we do is new w map dot set person for weak map, and then we set it again to 69, and then we clear out the reference person w map equals to null. And now what we do is, before this, the way to get something from a weak map is we do console.log. We cannot print its entries as such, right? So we need the key to get something out of it. Without the key we cannot. We need the key. That's a design decision, and we will understand why it's that way in some time. So if you print the new map, you will see how it prints it. And then we need to do get maybe person for w map, and we do the same thing for this person for w map after clearing the reference, and we can do the same thing here as well. Yeah, I think that will make the point. Let's try this. Let's try this. Okay, so this is what happens, right? So here you can see map will sort of explicitly hold on to this. If you print the entries, it will show you the entries. Like we have this, we have the name Sam, we have the person for map here. Even if we cleared out the references, it's still storing it somewhere. But like it's sort of like it's sort of keeping the reference indirectly. So even after making it null, you are sort of able to see it or able to access it. so it's still kind of accessible, right? But when you are doing something similar with weak map, once you lose the key, it's gone. Like you cannot access it. That's a sort of a design decision that or design choice that has been made, so that like the reference sort of allows garbage collection. So as you can see, the map sort of holds on to the keys when you don't clear out the, even after you clear out the references, right? So let's say if this were not this small, if it's were a very large object, so that would lead to a potential memory leak, right? But weak map is different. Weak map will only hold on to the key and its like value or whatever after like until you have the reference to it, then only you can access it. If you don't have the reference to it, it's not accessible. If it's not accessible, like we discussed, like the basis of garbage collector algorithm, the mark and sweep that we discussed, is accessibility. If it's not accessible, it's gone. Like in the next sweep, it will clear it out since it's not accessible. But that won't be the case for map. As you can see, even after making it null, it's still kind of accessible, so it will still sort of hold on to the key, right? So these are small things that you can use to optimize the use of memory in a day-to-day things. Like you can sort of look up for weak set also. That's also something similar rather than set. So sort of try to use these structures or these objects wherever possible, these types of objects, rather than using like map or set wherever you are sort of low on memory or you want to optimize for those aspects, right? So yeah, I think these are sort of one or two things that you can keep in mind, and like the initial things that we discussed, like like try using things which sort of use references than values, so that once you clear, you don't need to have to go back to everything else to check if it's leaking somewhere. Then you have like maybe setting unused references to null manually, so that it's easier for the garbage collector to sort of identify, okay, this is null. So it's like you are working with the garbage collector together to manage the memory rather than delegating the whole responsibility to the garbage collector. Like you are doing one or two small things here and there, which makes the work of the garbage collector a lot easier. And like believe me, it creates a lot of like these small things add up, and they adds up to the performance of the application a lot. Like the number of mistakes people make by not doing this, or what to say, it's not actually exactly a mistake, but I mean they don't take this into consideration, right? If you take it into consideration, it can be better, like your approach, so that it's easier and well managed memory for whatever like code you're writing, right? So yeah, I think that should be it for this video. I just wanted to sort of demonstrate what do I mean by what we meant by reachability and unreachability in the previous video. So we sort of got the glance of it, how this is reachable on even after clearing the reference, and how the next one is unreachable once we clear out the reference, right? So only unreachable things will be garbage collected. So try making things unreachable once you are done with them, if you can do manually or clearing out the reference, right? So yeah, that was the basic point of this video that I wanted to make. And if you liked it, like maybe share it with your friends, and if you have any suggestions, feel free to reach out to me or drop a comment. Okay, see you guys, bye.